In this video, you'll see the second set of our 4 core practices. We use these routines at the beginning of every unit. The first practice in this set is getting students to share what they know about an interesting science phenomenon or event. We refer to this as eliciting ideas, but this kind of discourse also activates a lot of prior knowledge so that students can understand which of their past experiences might be relevant to upcoming lessons. The second practice is selecting which of the students' ideas, past experiences, or puzzlements to make part of a public record. And finally, after the lesson is over, the teacher does a quick assessment of how the students talked about the anchoring event and uses that information to adapt further instruction. Because my novices have seen these practices before, I now invite them to help me do some of the teaching.
But what I'm thinking is some of you could actually help me do the actual teaching, little pieces of it. You do not have to volunteer for any of this. I'm just asking, does anybody want to do it with me?
I give my students choices for what kinds of roles they can take up in this apprenticeship. These range from a 1-minute setting up of the unit to an extended episode in which one of my novices will help the whole class negotiate which of their ideas will become part of the public record. On the day of the teaching, I step out in the hall with 4 students who have agreed to take on different roles.
I'll be like right beside you the whole time. Molly, you're looking like maybe you don't want me there. So who is doing the first thing, which is setting up the whole unit, doing like 60 seconds on Antarctica? Yeah. So, Reed, I'm going to have just one PowerPoint slide up there, the first one. Okay. It just shows the world and then Antarctica at the bottom of it. Then you're going to introduce the video, right? So what are you thinking about saying, Zach?
Well, when I watched the video, I found that they're mostly talking about differences between the penguins and the population, but we're focusing more on the actual Antarctic.
Do you want to just get as many ideas as you can out in the air or on the table?
And I'm writing them.
Nope.
Alright.
You are not. Right. Because we don't want to write anything on the board unless we want kids to really pay attention to that and record it in their notebook, and that it's going to be the basis of our conversation. Okay, so this is not, we're not planning for this to be perfect. We're planning just to show all these different things that you would do together in an integrated way. Awesome. Okay? All right.
As we begin teaching, our first brief task is to orient students to the topic we're studying and how it relates to previous units.
So we just finished our unit on individual organisms, and now we kind of want to look at how they all play as a whole unit. This idea of an ecosystem that we're talking about, we're going to focus on is Antarctica.
Moments later, another student introduces a video and asks us to pay attention to particular ideas.
Now we are going to watch a short video about a population of penguins in the Antarctic. And in the video, the makers of the video are interviewing a scientist who knows a lot about the penguins, and he's talking a lot about changes that are happening in the Antarctic. And I want you to think about, while you're watching this, think about what he means by changes. What kinds of changes might he be talking about? Also, as you're watching, they'll show a lot about the penguins in their environment. I want you to think about 2 things about their environment. How penguins live in the Antarctic and where in the Antarctic they seem to live. Just what you can tell from the video.
All right, I'm going to do the next piece, and then Molly's going to be right after me. So, in that movie, you were asked to think about what kinds of things are changing. What kinds of things did you see there that scientists talked about were changing?
They can get food easier.
The penguins can get food easier? And why was that?
Because the ice is breaking apart.
And what does the ice breaking apart?
So they can fish.
Okay.
The video said they need more open water. Open water has to do with feeding, right?
Yeah.
So what do you think about Molly saying sea ice is important, you're saying open water is important? What's the relationship between them?
Well, if there's more breaking up of the ice, there will be more open water. And they also said something about melting the sea ice. I'm not sure what the connection is.
After this brief introduction to the ecosystem we'll be studying, I now introduce the puzzling event, something that has transpired over decades.
Two different species. And one of these species, the Adelie penguin, is the subject of a lot of study by these scientists. And they've tracked these Adelie penguins over the last probably 35 to 40 years, and they have data on how many Adelie penguins there are. This graph is going to be of the number of breeding pairs of Adelie penguins. And so we're going to take a look at that, the number of breeding pairs. I want you to just look at that, and then I want you to turn and talk to your neighbor for just a minute about what it is you see here in the graph. Molly, this is you. You're going to come up and
Just take a look at this graph, and kind of what scientists do with data is we need to learn how to look at the data we have and realize its potential limitations or patterns. And I just wanted to know if you guys recognize anything about this graph that you find noteworthy before we continue. Free?
Well, sometimes there's lines connecting dots and sometimes there's not. I don't know why.
Why do you think?
I don't know. Where there's not lines, there's a bigger gap between the dots. But then all of a sudden there's like a little line, and then it's not there anymore, and then you have a long stretch at the end.
So, Amanda, you're confused too. Do you have any idea what the dots might represent?
Actual times when scientists counted the number of breeding pairs.
Yeah, that's a really
But I don't know why they're not connected.
Looks like they counted more times, starting around 1990. So maybe before that, they didn't count enough that they feel like they can draw a line.
It's a really interesting point. Yeah, I think the lines here kind of represent a connect the dots sort of pattern they're trying to show. And you can only establish this pattern if they have enough dots or pieces of evidence about the breeding pairs. Just basically, what happened to the population of the penguins?
Penguins died.
They died.
Maybe they had disease.
Yeah,
Maybe the weather was really bad that year.
Maybe a lot of the ice melted and then more ice grew back.
This is great. So we're actually getting into the how. We're getting into the how question about the declining population. So Paige, you think the ice has something to do with it?
Well, they're standing on ice. Yes, I do.
So why is the ice important for the penguins?
Because they live on the ice and they breed on the ice and they can't survive, like they can't just swim all the time. They need ice.
Graham?
I'm thinking of the image in the video where it showed their nesting grounds getting blasted by a blizzard. And the narrator explained that the climate conditions in those high ridges have been changing and receiving more precipitation. So I'm imagining that their nesting grounds are less safe of a place for nesting grounds than they used to be. So if we take the same number of penguins and have them compete for a smaller amount of appropriate nesting ground, their actual reproduction could be less effective.
And what makes you think that it used to be safe?
I'm trusting the narrator that says that the climate conditions on those high ridges are changing.
Does the graph help with that idea?
Yeah, the graph supports the idea that the number of breeding pairs is going down.
So let me interject something as a teacher. So Graham's making a claim. So scientists often make claims. So Graham's making the claim that the number of breeding pairs over time is going down. Is that what that graph is saying? So could you, what?
I kind of skipped the whole overarching
Yeah, that's okay. So we want to cover all the fundamental bases first about whether the students in the room are seeing the same things in the graph. So if you had to tell a little story that was like a couple sentences long to somebody about what's happening with the penguins, and you didn't have that graph to show the person, what would that 2-sentence story be?
Between 1975 and the early 2000s, the number of breeding pairs of Adelie penguins has dropped in the Arctic.
Okay. Does anybody want to add to Paige's story or change a part of Paige's story? A friendly amendment, we'll call it. Tina first.
I would like to add that for the first 10-ish years, the drop seemed to be kind of slower, and then the last 10 or so years, it dropped more rapidly, the population, the number of breeding pairs.
There's been, over the overall data, there's been a drop of more than 20,000 penguins. That's the decrease, not just that they've been plummeting, but like individual penguins.
So Molly, you're doing the right thing by asking about why would you collect data on breeding penguins. But if a student is hesitating, back the question up to a little bit easier of a question, like what do we mean by a pair of penguins that's breeding?
Yeah.
That's a little bit easier, and then kids can contribute, and then maybe that will trigger something for Amanda and others.
What do we mean by a pair of penguins that's breeding?
That means they're making babies.
They're old enough to live through a winter.
How do you know that?
Because they're breeding. Like it's not like the runs of the litter that are just gonna like die in that first month. It's not just like every single penguin that's on the ice. It's the ones that kind of like matter.
And why does breeding, in your words, make an organism matter?
Because it's gonna keep like passing on its DNA.
Okay, we've burned out Molly's brain cells by having her do all this thinking. Let's give a hand to Molly. So if we were to do this second period, if we were to teach this section the second period, what Molly might start off with is just 5 minutes of having you all just say, what do I see in the graph? Let's not speculate right off about why the decline, but let's talk about what do you see in the graph? And so what are some simple things you can do for kids to make meaning out of graphs? How do you begin to make sense out of that graph?
Could you put the story of this graph in 1 or 2 sentences? I like that part about it.
Yeah, that would come maybe third or fourth, because you have to understand the parts of the graph. So what precedes that? Marie?
I would ask what the numbers on the axes mean.
What does the dot mean?
Yeah, what are your
What does one dot mean?
Yeah, where the
And
heck
then
is?
what does the trend mean?
What's wrong with this graph?
Would it be helpful to ask the students about how you think scientists got this data? Or would you want to just, would you want to just tell them, or you would ask them?
This is one mistake that I made in designing this, because maybe Dennis, you remember something I said last week.
Right, telling.
Kids, yeah, you want to say it?
I'd love to say it. So really it helps to kids or students to understand graphs when you tell them how the data was collected, or basically so they can understand what that little point means. So you would say something about in 1975, some scientists went out and in some way, maybe with an airplane or a boat, went and counted all the penguins, or maybe they counted a section and they extrapolated that out.
Would be a good time to say, they didn't just count all the penguins.
Yeah.
They counted the ones that were together on a nest.
Yes. Yeah. Would you tell them about extrapolating out data? I mean, I feel like the students would be like, wait, they counted 15,000 breeding pairs?
It is possible that scientists actually identify 15,000. Right. Because they have graduate students who do that.
That's the guess.
But let's go back to Marie's thing about what do the axes mean? So the bottom axis is pretty easy to understand, it's years. And then the vertical axis is a little harder because some of you had to explain what a breeding pair is. And then why would scientists care about breeding pairs? Well, who's not? What penguins are not on this chart then?
At this point, we are only partway done with our eliciting practices. We've had 3 different novice teachers play roles in the instruction. And of course, it's always a bit clunky to try to transition from one teacher to another during these simulated lessons. It also takes longer when I stop the action to ask for a replay or simply to offer comments. But it is critical for us to be aware of choices that we are making that allow more students to participate and to reason about the science. In the next video, you'll see the other half of this eliciting practice in which our students create public records of their thinking in the forms of small group models and a list of hypotheses about why they think this phenomenon is happening.